In section 1.6, we're going to be talking about transformations. And if you look in your ebook and find this particular page, this is going to be your parent graphs, and this is really good to just have a printout of, because all of the stuff we're going to be doing today, the transformations, we're going to be moving and shifting these parent graphs. So you want to be familiar with the basics of each of the parent graphs, which this one's a constant function, and you can see down here it gives your domain range and tells whether it's an even function or an odd function, and we talked about that in a previous lesson. You have your identity function, absolute value makes like a V, quadratic, or most often you familiar with it as a parabola. Your square root function is going to be this one, cubic function, and cube root function. So if you'd like to print a handout of these particular parent graphs, that would be useful. Alright, and we get into our vertical shifts first of all. And we say if we have a function and we have plus c, it's the graph of the function shifted up c units. So in this case, this plus c means shifted up c units. The next definition we say if the graph of the function y equals f of x, this is one of our parent graphs, this part, minus c, then we say it's the function shifted down c units. So in this one, we're going to go down. So if you have plus c, we're moving up, minus c, we're going to be shifted down. Alright, the idea of what we're going to do with these first graphs is we're going to graph our parent function over here, or in this case it's noted as a standard function, and then we're going to work the transformation over here so we can see what the original parent function or standard function looks like and compare it to the transformation. These are all going to be rough sketches. These aren't exact values, but our parabola, our x squared function on the parent graph looks similar to that. Okay, and then for our transformation, we're going to look at this. This is our parent function f of x, and then this is plus 2. So what do you think we do to our parent function? Go up 2. So if this goes through the ordered pair 0, 0, for example, if we use that one particular point, then our transformation, we're going to be up 2 units from that, and then try to sketch the same f of x. So here we would say up 2 units. Take your vertex and shift it up 2 units. Now, in your homework or later, if you was to give exact values of these, we could make XY tables and plug these values in to get the exact coordinates. Right now, for the sake of just understanding transformations, we're going to do rough sketches. But if you need exact coordinates, just make an XY table, plug in points like we did previously. In this next one, what is our function? What do you think our f of x is? Square root of x. It's the square root of x function. So we want to consider our standard graph and graph it here. And then we want the transformation of the g of x function to be over here. So we want to graph f of x on this side. F of x is equal to the square root of x. Roughly. That's a bad one. Okay. And then we want to, that's our f of x. Then we have minus 2. So what do you think's going on? Let's say if this is 0, 0. What do we do with that? We go down 2, and we have that same thing. So this is our g of x, which is square root of x minus 2. So we shift it down 2. In this next one, our f of x function is the absolute value of x, which the parent function or the standard function is like a V, and so this is our f of x, which is the absolute value of x. Okay, and we're asked to graph our transformation, use transformations to graph g of x, which is absolute value of x minus 3. So what do you think this minus 3 would mean? Shift down 3 units. So let's shift this thing down 3 units roughly. Like I said, these are all rough sketches. If you have to find exact values, you would make a table, plug in values for the exact points. Alright, and we move on. We have a standard function. This time our f of x is x cubed. And this one's always kind of tough for me to draw. It looks something like that. So our g of x function over here is going to be x cubed minus 2. So this minus 2 means to shift down 2 units. That means point for point for point, whatever points they have over here, every point shifted down 2 units in this particular graph. So, and the easiest way for me is if I grab this point right here, which is 0, 0, that's the point I'm going to shift down. So I kind of make a dot there, and then that's where my graph changes there. So this, we have a different presentation. It says use the graph of a function f, which is over here, our f of x, and they want us to use just this information to produce our g of x over here. So g of x, they are asking us to graph the original function that was given to us, and what does the plus 1 mean to do? Shift up 1. So any ideas on shifting this thing up 1? If I look at this, I'm going to pick particular points. So 0, 0 is the easiest one. If I come over here and shift up 1, that will put me here. This is the point, what's that? Negative 4, 4. And if I shift it up 1, so negative 4, 4, shift it up 1. And then this is the ordered pair 4, 4. Whoops. And shift it up 1. It's hard to see on this thing, those numbers. And then sketch that. Okay, so you can do that as well. The next concept that we visit is our horizontal shifts. So we leave our vertical shifts, and now we're going to focus on horizontal. The graph of f of x plus c, this time it's in the parenthesis, is the graph of f of x shifted to the left c units. Now I want you to really look at this. I want you to notice that that's a plus c, but we want to go left. So in a sense, you want to kind of think opposite when we're talking about the horizontal shifts. And that's one you're just going to have to remember. If you get tripped up any, it's usually that'll get you. And also, if it's minus c within the parenthesis, then we think opposite, and we're going to shift that to the right. Okay, let's look at some examples. So our parent function, our standard function, is the x squared, which is a parabola going through 0, 0. And we want to look inside the parenthesis, and if this is a plus 2, what are we going to be doing? Shifting to the left 2. So shift left 2. That's code for shift left 2 units. So for our g of x function, we're going to take our 0, 0, shift it to the left 2 units, sketch our graph. Good.